Hello everyone, welcome to today's lesson on linear equation forms. So the past few lessons, we've talked about the standard form, which is this one here, and then the slope-intercept form, which is here. Right? And now today we're going to learn a new form called the point-slope form, and then we're going to learn about how to convert between all those three forms. Right? Because each of those forms exist for a reason, right? And they accomplish different things very easily. So, just a quick little review here. The standard form, right, will be something like this, right? Where, importantly, a, b, and c are integers. Right? So not decimals, not fractions, but integers. Right? So it's essentially a number x plus a number y equals to c. In a slope-intercept form, right? This is where we got our slope of m and b of the y-intercept here. Right? Of course, if, let's say, for example, we have this equation here in the standard form, right? If we want to figure out what the y-intercept and the slope of this equation is, we can easily just convert it into the slope-intercept form. Right? Because right here, we can't really tell right away what's the slope and the y-intercept. But what we can do is to put into this form. Okay, so it's just going to take a bit of rearranging. So first step here, we want y to be by itself. So we subtract 2x from both sides. Like that. Right? So all we're doing here is to move this 2x onto this side so we can isolate the y. After that, of course, we divide both sides by -3. Right? So we get -2 divided by -3 is positive 2 over 3x. Plus 12 divided by -3 is -4. Right? And then that's it. That's our slope-intercept form. So from there, we know that the y-intercept is 0, -4. Right? That's the constant here. And the slope here is just the coefficient of dx, which is 2 over 3. Right? So again, we cannot really easily tell from the standard form, but by converting to the slope-intercept form, we can easily tell what the y-intercept and the slope is. Okay, and now, with just another equation we could convert to. There's just this point-slope form. Right, so now the point-slope form is useful when we have one point and one slope, right? Sometimes we don't really know what the y-intercept is, but luckily, we do know a single point that the line will cross through. So, all it is we have y here, minus, right? So make sure we are careful about the signs here, right? We have minus the y value of the point equals to the slope times the bracket x minus the x value of the set point. Okay, so for example, let's say we got an equation here with the slope of 2 and it runs through this specific point. Okay, so let's set up our equation here. It's going to be y minus y1 equals to dot, dot, dot. Okay, so we know what the slope is, which is 2. We can replace the m with 2. That's the slope. Next, we have a point that runs through -4, 1. Okay, so we can now replace our y and x. Right. The y here, the point of the point is 1. And the x here of the point is -4. Okay, so this becomes +4. Okay, and that's it. Okay, so there's a point-slope form. Again, it's very useful when so that's the x and then the y of the point. It's useful when we only know one point, that's not the y-intercept and the slope. Okay, so now let's try this. How about a line with a slope of 4 over 5 that passes through this point? Okay, so if we are given a point and a slope, the easiest form to find is the point-slope form. Okay, so once again, we're subtracting the y value, which is -2, so it's y plus 2, equals to the slope, which is 4 over 5, and then x minus, right, the x value of the point, and that's it. Okay, so that is our point-slope form. Next, let's convert it into the slope-intercept. Okay. So what we can do here is to get rid of the brackets. Right. We're just expanding the bracket here. Right. And all we have to do is to move the 2 to the other side to isolate the y. Right, just like that. Okay, so again, that's the point slope. Slope-intercept is this one. Right, so keep in mind when we are subtracting this fraction by 2 here, we're essentially just doing 12 over 5 minus 10 over 5. Right? This is what 2 is. Okay, how about the general form? Right, so remember, with general form, we can only have integers, right? So which means that somehow we have to get rid of this fraction. Right? Fraction is not an integer, it's a rational number. So now to get rid of this fraction, we can multiply everything by 5. Right? Because when we do that, we get 5y plus 10. Right? That's 5 times y and then 5 times 2. When we multiply this by fraction by 5, that cancels out. Right, to get this. Next, we expand out the bracket. Right, and then lastly, we want to make sure that the x and the y are on one side and then the constants are on the other side. Right, so we can minus 4x at both sides to move it, and then minus 10 to both sides to move the constant over. So we get negative 4x plus 5y equals 222. Okay, that's a general form. Or standard form, sorry. Guys, same word, same thing. General form, standard form, same idea. Right, so that's how we convert between the three. Right, so at this point, this is pretty much just rearranging the variables. Okay? How about when we're given a graph only? Okay, so right away, we notice here that we have a point here. Let's say this one. Doesn't matter which one we pick. That's what I'm for. I picked this one just because it's positive numbers. That's easier for me to work with. Right, we have a point here. So all we need now is a slope, right? Because if we find a slope, so there's 3 to the right, and then 5 up, right? Because right away, we found a point and we found a slope. So we can easily just find the point slope one. Right, so y minus a point equals to the slope, which is, now 3 over 5, 5 over 3. And then x minus the point, which is 1. Right? Of course, this works as well, right? Doesn't matter which point you pick. Right? This point is what? Negative 2, negative 1. So if you were to put in, because it's negative, actually, I'll just put it here. Right, we know this point here is negative 2, negative 1. So we could easily, or not easily, but we can also just put our point here, same slope. Right, this right here is also an acceptable answer, right? Because if we were to multiply everything else, it's actually the exact same number. Right, so yeah, it doesn't matter which point you take, as long as it's a point anywhere on this line, that's completely fine. Okay, so once again, let's convert it into the slope-intercept form. I'm just gonna use this one here. Okay, so we can expand out the 5 over 3. And then move the constant to the other side. So it's y equals to 5 over 3x plus 7 over 3. Right, which means that, again, this is the same slope of 5 over 3. The y-intercept is 7 over 3. Right, which kind of makes sense, right? We know this is between the 2 and the 3. Okay, so it's around 1/3 up. Yeah, that kind of makes sense. And then the general form, of course. Right, again, we want to get rid of fractions. I'll just use the dot just to say it's consistent. I don't really watch back my videos that much, so I wonder how inconsistent I am with using all those signs, right? Sometimes I use the X, sometimes I use a dot. But anyways, we multiply everything by 3 to get rid of this fraction here. Expand this guy out. Right? Expand out the brackets. And then we move all the x's on x and y on one side, and the constants on the other side. Right? So we subtract 5x from both sides while adding 12. So we get negative 5x plus 3y equals to 7. Okay, just like that. Okay, here we go again. Parallel or perpendicular, or neither. Okay, so, of course, to figure out if they are parallel or perpendicular, right, we just have to find a slope of those two equations. Of course, they're in general form, so we need to convert it into either the point slope form or the slope intercept form. Okay, so of course, it's usually easier to convert it into into the slope intercept form. So we want y to be on one side. Oh, actually, let's do x first. This is consistent. Okay. Divide both sides by 3. Okay, so the slope of the first equation is this. Okay, now let's convert the second one. Right, for this one, we can just, oh, sorry, not add y. Move the 2x. And then divide everything by -1. Essentially just flipping the signs. Right, so the slope here is 2. Right? And of course, this doesn't match any of the descriptions, right? For parallel lines, they have to be the same slope. For perpendicular, it has to be negative reciprocal. So when we flip it over and add a negative sign, right? So a line perpendicular to this should be positive 3/4. So that is to say, it is neither. Okay? Here's our last example here. So we want a slope intercept. Right? Make sure we read the questions carefully. Right? If you give me a general form, right? Unfortunately, I'm not going to take that as an answer. Right? And we want a line that's parallel and a line that's perpendicular to this line here. Okay, so of course, because we're working with slopes, right? Let's convert this guy into our slope intercept form. Right, we can take away 3x from both sides. Divide everything by -2. Oh, -2, so that's positive 3/2. Okay, so this is our slope intercept form. So if we want, right, if we want a line that's parallel, right, we need the slope of 3/2, right? It has to be exact same slope. And if we want a line that's perpendicular, we want a negative reciprocal, so it's going to be -2/3. Okay, but it's not just any line, right? This line has to pass through this exact point. Okay, so we can just first plot it into our point slope form. right? Because we are given a slope and a point, right? So we have plus 2 and x minus 4. Once again, plus 2 is how the slope is different, right? But the point is the same. Right? Negative 2 becomes positive 2 here, and then 4 becomes minus 4 here. Okay? But remember, we want our answer to be in slope-intercept form. So, of course, that means our last step is to convert both of those into the slope-intercept form. So here we subtract 2, 3 over 2x minus 8. So that's one of them. That's a line that's parallel. Same thing here. Oh, I should probably expand that first. Negative 2 over 3 plus 8 over 9. Just kidding, over 3. Subtract 2 from both. Negative 2 over 3x plus 2 over 3. Okay, just like that. Done. Okay. Hey, so in this lesson, we just learned one single new concept, which is the point slope form. Right? But most of the lesson is converting between each of the forms. Right? Once again, the slope-intercept form is very useful to quickly find the slope and the y-intercept. Point slope form is useful if we have a slope and a point that's not the y-intercept. And it's standard form ax plus by equals to c. Right? That's useful when we want to find the x and y-intercepts. Right? We just replace one value with 0 and then the x value with 0 and y value with 0 to quickly find the x and y-intercepts. Okay, so all those forms do different things, and they're very useful when we convert them back and forth. Okay, so with that being said, good luck practicing.